Alright, hey guys, it's Miss Summers with your notes today on geohazards. So this is going to be our last set of notes before our test this Friday, October 2nd. So we've looked at plate tectonics, we looked at continental drift, plate boundaries, earthquakes, and volcanoes. So now we're going to bring in the human element. How do these events in the geosphere affect people and their property? And more importantly, what can be done to try to mitigate that or make that effect not so great? All right, so we're going to be looking at three categories of geohazards. We're going to look at geohazards caused by volcanoes, geohazards caused by earthquakes, and then we will have one that is caused by both earthquakes and volcanoes. All right, so let's start by identifying what a geohazard is. Geo, again, just means earth, and hazard is something dangerous. So a geohazard is an event caused by a geologic feature. So it has to start in the ground, like a volcano or an earthquake or something like that. That causes severe threats to people and property. All right, so again, we're focusing mainly on those volcanoes and earthquakes. So let's start by looking at events or geohazards associated with volcanoes first. All right, when a volcano erupts, the most immediate geohazard is going to be ash and ash clouds. So volcanic ash gets ejected into the atmosphere, all right, during explosive eruption. So remember that high silica magma that's really, really viscous. It's really, really thick, kind of like peanut butter almost. All right, the gases get trapped, so it's a bigger kaboom. With volcanic ash, it's not like ash that you would see in like a fire pit or like a fireplace. Like that ash is soft and like dissolves in water. Volcanic ash is little itty bitty tiny fragments of rock. So it's sharp and abrasive. This is like a microscopic view of it. It's like glass almost. So if you were to breathe this in, if you were in the area and you were to breathe this, it would tear up and scratch the insides of your body. It would tear up your trachea and your lungs, and it would be very hard to breathe. And that's obviously a really big deal because we need that to survive. Ash, there's also going to be a lot of it raining down from a volcanic eruption. It's heavy. So you can see in this picture, these are like trees. I think this is in Indonesia somewhere. The ash is weighed down the leaves, and that's why they look kind of droopy and sad. All right, if this were to pile onto like a roof of a building, depending on how that building is made, the roof might not be able to support that weight, and it could collapse, and that's another danger. Right? So ash, depending on the size of the volcano, that's going to determine how widespread the ash fallout is. So in Yellowstone, remember Yellowstone is on that hot spot, so it's not necessarily on a plate boundary. All right, but the plate's moving over it. All right, Yellowstone is a super volcano. Yellowstone will erupt eventually. We don't know when. It is kind of getting close to when we would expect another eruption to happen, so that's why people are kind of interested in it now. All right, when Yellowstone erupts, anything living basically in the state of Wyoming is going to not survive, unfortunately. All right, because it's going to be that explosive of an eruption. All right, but even hundreds of miles away in other states like Minnesota, Missouri, the northern part of Texas, you're still going to have some ash fallout. Even us, way over here in North Carolina, all right, we are probably well over 1,000 miles away from Yellowstone. All right, we would still be affected by that ash in some manner. All right. So volcanic ash is not just going to affect the folks who are right next to the volcano. Obviously, they're going to feel the most effects first. All right, they're going to be the ones immediately impacted, but there's a long-term impact of volcanic ash. And I want to show you this little story about this place called Mount Tambora. All right, just a little reference. Mount Tambora is a volcano here in Indonesia, way the heck over here, almost by Australia. All right, so I want you to listen for how did Mount Tambora affect people that didn't even live near the volcano, and how did it affect them for years afterwards? We're going to watch this video, only the first couple minutes of it. We're going to say no ads, YouTube. Perfect.
On April the 5th, 1815, in Indonesia, a volcano by the name of Mount Tambora erupted. Locally, the effects were devastating, according to William and Nicholas Klingerman in their book The Year Without Summer, 1816, and the volcano that darkened the world and changed history. An entire population on the island of Sumbawa was killed, and the British sailors in the area reported entire islands of pumice that had to be cleared. The Lieutenant Governor of Java heard the blast 800 miles away, and assumed it to be cannon fire from somewhere in the distance. Troops were dispatched to defend a neighbouring town, and coastal cities sent out ships in search for a ship in distress, assuming that someone was firing the cannons to signal an emergency. While the effects were devastating locally, worldwide it was hardly noticed at the time. It wasn't until modern science began to look more deeply into it that the full impact of this volcano in a remote region of the world was fully understood. It is considered one of the most powerful volcanic eruptions to have ever occurred in documented history, with some even calling it a supervolcano. With an even more devastating impact than 1980's eruption of Mount St. Helens in Washington, the eruption was so violent it caused Tambora to blow off much of its summit. It went from around 4,000 metres to 2,850 metres above sea level. Here are 5 effects that the Mount Tambora eruption of 1815 had on the world, some of which can still be seen today. The summer of 1816 was so cold, there was snow reported in June. Most crops failed because of such a short growing season. People actually had to wear coats during the 4th of July celebration in Washington, D.C. All over the Northern Hemisphere, the cold weather was devastating. Crops failed in both the UK and the US. The economic impact this had on the world was extreme, as much of the people were already in a state of depression following the end of the War of 1812. Clockmaker Chauncey Jerome, a resident of Plymouth, Connecticut at the time, recorded in his journal that on the 7th of June, already dressed in thick woolen clothes and an overcoat, he had to put his tools down and put on a pair of mittens because his hands had gotten so cold. Even China and Tibet reported unusual weather. In June of 1816, the logbook of one ship exploring the South Sea noted that the landscape still appeared to be like winter.
Alright, so we'll leave it right there for right now. And we'll go back here. So the long-term impact of this volcanic ash is that it can change climate. Alright, so the ash, if you recall from the video, Mount Tambora literally got about 3,000 feet shorter. All that rock, okay, most of that rock was blown apart in the eruption and ended up in the atmosphere. That blocked out the sunlight. It scattered the sunlight so the surface didn't heat up as much, and that's what ultimately affected the climate. Right? Our next geohazard associated with volcanoes is called a lahar. A lahar is a mud flow caused by ash mixing with melted snow. So this will happen mostly at like stratovolcanoes. Remember the really tall ones, all right? Even though, we think of volcanoes as being hot, if a volcano is really tall, it can have snow on the top of it. That's totally normal. So if it erupts, that hot lava will melt the snow and it'll become a mud flow, all right? And this will slide down the mountain and it will destroy everything in its path, all right? The example I want to show you, we're not going to watch the entire video of this. It is the tragedy that occurred in Armero, all right? I just want us to look at what could have been done differently for this particular town. So we'll go here. We'll say no ads, no ads, no ads.
Imagine the
Oh,
places
we have an
we'll go.
ad. It's okay.
Together.
Look, it's a vacation. Do
Expedia.
you remember those? I don't.
On November
There we go.
13th, 1985, the Nevado del Ruiz volcano erupted in Colombia.
Pyroclastic flows exploding from the crater melted the mountain's ice caps, forming lahars, volcanic mud flows and debris flows, which cascaded into the river valleys below. One lahar, consisting of 3 pulses, did most of the damage. Traveling at 20 feet per second, the first pulse enveloped most of the town of Armero, killing up to 20,000 people. In total, 23,000 people were killed, and 13 villages in addition to Armero were destroyed. Since there had been no substantial eruption since 1845, officials dismissed safety and evacuation planning. To make things worse, Armero and many other villages were in the path of the volcano's destruction. 2 months before the main eruption, earthquakes and phreatic eruptions rocked the area around the volcano, and that's when officials finally began planning for evacuation. A hazard map was prepared in October, but the map was poorly distributed to those at highest risk. Many survivors had never heard of it, though several major newspapers had featured it. Omaira Sanchez and her family lived in Armero at the time of the eruption. On the night of the disaster, Omaira and her family were awake, worrying about the ashfall from the eruption, when they heard the sound of an approaching lahar.
Alright, so I'll pause the video there. So Omaira, this little girl, she ended up getting trapped in the debris of her home from this lahar. She ended up being trapped for about 3 days. Rescuers couldn't pull her out without breaking her legs. And ultimately, the decision came down to, well, we can either try to amputate her legs, and we can free her that way, or, we can just try to keep her comfortable until she passes on. And that's ultimately what they decided. She died about 3 days afterwards. But Omaira and her family, again in Armero, the worst part about this tragedy, the people in Colombia, they could not have stopped this lahar from happening, because that was a result from the volcanic eruption. There was no way to stop the event, but they could have communicated this evacuation plan to the people who needed it most, like Omaira and her family. And had that been done with enough time in advance, there's a good chance that a lot more people would have been saved. Okay. Our last and final geohazard associated with volcanoes are called pyroclastic flows. All right, so pyro means fire, which just lets you know that this is something that's really, really hot. So it's a current of superheated gases and ash. So it's kind of like an avalanche of ash. It moves really, really fast, 60 miles an hour plus, and it literally destroys everything in its path. There is no way to outrun it. The only way to survive it is to not be in its way. All right. The most famous example of the fallout of a pyroclastic flow can be seen here at Pompeii and Herculaneum in Italy. Pompeii was both these were Roman towns at the base of Mount Vesuvius, which is in Naples, Italy. And it erupted in 79 AD. That's not the last time it erupted, but that was the last really major eruption. And the people in Pompeii, they didn't realize Vesuvius was a volcano because they had never seen it erupt before. So it didn't dawn on them what that was. So obviously it starts erupting on an August day in 79 AD, and people start freaking out because they're like, what's happening? What on earth is this? What is this? And a lot of people didn't know what to do, so they just kind of stayed at their homes trying to seek shelter. And this pyroclastic flow ends up hitting the town and burying it in ash and killing everybody and everything in this place. So what is left, 2,000 years later, this town was covered in ash. These bodies were covered in ash. The bodies themselves of the people, they have long since decayed and decomposed, and they're not there anymore. But there was spaces left in the rock where their bodies were. So that's what you're looking at here. They're casts, kind of like shadows, if you will. This is a dog, obviously, who unfortunately met the same fate as its master. So archaeologists have been able to use, these remains from the pyroclastic flow, in a way it's really preserved what this town was like on that day that this eruption happened. But yeah, it's very devastating. Definitely don't want to be in the way of it. All right. So for volcanoes, we have our ash we have to worry about. We have our lahars, which are our mud flows that comes from the melted snow and lava. And then our pyroclastic flows. Our next events are going to be geohazards associated with earthquakes. All right, we have two of these. Our first one are landslides, which is just what it sounds like. It's when a chunk of land slides down a slope. All right, remember, an earthquake is just a vibration in the ground, so it can knock things loose. This is more likely to happen in very mountainous areas, especially if it's been raining a lot and the soil is saturated or soaked in water. It's very slippery and can move very easily. All right, so just like a lahar, it's going to basically knock everything down in its way. Soil liquefaction is specific to earthquakes. This is kind of an interesting phenomenon. So what happens, we normally think of soil as being solid. Okay, we can walk on it, we don't sink into it. But during an earthquake, when the ground shakes, it allows the water in the ground. Okay, so there's normally water in the ground, that's normal. That water will come up between the soil particles and it will reduce how strong the soil is. So the soil goes from being a solid to being more like quicksand, and objects will sink into it or tilt or collapse. Okay, normally we build buildings on strong foundations. We build it on solid ground. Well, if the ground isn't solid anymore, your building's going to tip over. So I have this little video that I want to show you. I don't want any sound with it though. Let's see if I can skip through. I don't need all of this mess. No, how can I skip through it? Okay, so basically what they have, this is how they model soil liquefaction in a lab setting. So you have an earthquake table. We have these buildings. Whoops. They have shaken the ground. Let's see if we can. I want to reverse that. I don't want to exit it though. Let's see if we can do it. Okay, here we go. Okay, so this is an earthquake table. It will shake. So as it shakes, watch the building sink, 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 sink. And you can see over here on the sides, you can see the water coming up. That's why the soil became weaker. All right, that water is able to come up through those vibrations. Yay, that's soil liquefaction. All right, and our final geohazard of the notes are tsunamis. Wear your mask, JJ. Okay, that's fine. All right, a tsunami is a series of waves that can be caused by an earthquake or a volcano as it displaces water. What I mean by displace water, pretend you have a rock and you throw it into a pond. It pushes that water out of the way. That's essentially what a tsunami is. Tsunamis are very, very dangerous. They can be very devastating. In deep water, where earthquakes tend to happen, all right, on the ocean floor, the tsunami is not very tall. But as the tsunami spreads out, all right, as it reaches the land, the seafloor gets shallower and shallower. This water will slow down and the water piles on top of itself. So that's why this wall is taller than it is out here. Okay, so it's kind of hard to tell if a tsunami is happening out here, but you know once you're on land. So here's a little demonstration of how this works. This is a model of what happened in the 2004 tsunami in the Indian Ocean. We see the friction there from the plates, those converging plates. It breaks. There's the earthquake. You see how this land sort of jumped up and pushed all this water out of the way? That water had to go somewhere in the form of that tsunami. So we can actually watch that again. No, watch it again. Watch it again. All right, so there's my subducting plate, there's my earthquake, and there's my tsunami. So it goes out in all directions. It kind of goes out like a ripple, And it's not just one wave. It can be several waves. All right. So again, as I mentioned, the tsunami I want to focus on is the Boxing Day tsunami, or the Indian Ocean tsunami of 2004. Just a quick background. It happened on Boxing Day, which is December 26th, the day after Christmas. It's a big European holiday. It's more of a European holiday than it is here in America. And it happened in Indonesia, around Sumatra and Thailand, where a lot of people vacation, in addition to a lot of people just live there. So I want to take a look at this video, and again, I want you to think about what could have been done differently. What could have been done differently to help more people? Are we going to say no ads? Nope, we have another Expedia ad. Oh, that's adorable. I love it.
The worst forms of natural disasters. As an example, the 2004 Indian Ocean tsunami, which had waves
So
as
why
high
was
as
it so
30
deadly?
meters tall, once heading inland, killed approximately 230,000 people in 14 separate countries, making it one of the worst natural disasters ever in recorded history. Tsunamis, unlike normal waves, which are caused by the winds and tides by the gravitational pull of the moon, are caused by extremely large displacements of water. In the case of the Indian Ocean tsunami, it was caused by a large undersea megathrust earthquake that measured 9.2 in magnitude. This earthquake occurred along a 1,600-kilometer subduction zone where the Indian plate slid under the overriding Burma plate. As the overriding Burma plate bulged under strain, tectonic uplift occurred before eventually the plate slipped, causing a massive amount of energy to be released, and thus causing a tsunami. This earthquake, which displaced an estimated 30 cubic kilometers of water, created waves with an energy equivalent of 5 megatons of TNT, which is more than twice the total explosive energy used during all of World War II. On average, 2 tsunamis occur per year, and approximately once every 15 years, a very large destructive tsunami strikes. You may be asking then, what made this particular earthquake and subsequent tsunami just so deadly, and how can this be prevented in the future? One reason is the close proximity of the earthquake to land and the extreme speeds at which a tsunami moves. The hypocenter of the earthquake was approximately 160
hypocenter is
kilometers
another
off
word
the
for
western
epicenter.
coast of northern Sumatra within the Indian Ocean. Just 20 minutes after the earthquake occurred, the first waves were arriving at the northern tip of Sumatra, instantly killing nearly 100,000 people. Then, an hour and a half later, the waves hit Thailand, resulting in similar death and destruction. These waves continued to expand outward from the epicenter of the earthquake at a rate of about 500 miles per hour, or about the speed of a commercial jetliner, hitting all of the surrounding landmasses and bringing with it extreme amounts of destruction. The second and related reason as to why the tsunami was so destructive was that despite having some amount of time, although limited, between when the initial earthquake occurred and when the tsunami arrived, many of the countries hit by the tsunami were completely taken by surprise. At the time, there were no tsunami warning systems located in the Indian Ocean to provide any advanced warning, making it impossible for anyone to know what was about to occur. And all that being said, tsunami detection is not easy, as often the water disturbances occur in very deep water in which earthquakes may not be easily felt.
All right, so we'll pause it there. So again, just like with the Lahar that hit Armero and Elmira and her family, these folks didn't realize what the warning signs of a tsunami were. They didn't have any warning like, hey guys, there's a tsunami coming. Y'all might want to head inland, friends. All right, the very tragic thing about this, you can see it in this picture, especially, one of the warning signs that a tsunami might be about to happen is the water will retreat, so the water levels will drop very suddenly. And that happened in Thailand, and people were like, the curiosity got the better of them, and they're like, oh, I wonder why that's happening. That's kind of cool. Like, what's going on? So they went down to like go explore or whatever, and then minutes later, this monster wave that's like literally in some places like almost 100 feet tall just barrels in, and there's no way to like really outrun it. And water, water's a very powerful thing, especially when it's moving really, really fast. So unfortunately, a lot more could have been done to protect, tens of thousands of people from this terrible, terrible, terrible disaster. All right. So that concludes our notes for today on the different geohazards. Your assignment today, it's kind of a fun assignment. You're going to be looking at how can disasters be prepared for? And you're going to look at how you're going to do that. All right? So, let me know if you have any questions, and I will see y'all soon.